when theta is 0? Technically it's 0, right? The opposite side, we were here, and there's your triangle. As theta goes towards 0, the opposite side shrinks and shrinks and shrinks down to 0. So technically, and this is the unit circle, your opposite side is, when you have a terminal ray right on the x-axis, your opposite side is technically 0. Over your hypotenuse is what? 1, always 1. So that's the reason for the sign of 0 being 0. Because it's the opposite side, which is 0, over the hypotenuse, which is 1. So there's your point 0, 0. The sign of 0 is 0. Now, as that increases to a 30-degree angle, which would be pi over 6, right? Where's pi over 6? Here's pi over 2. So if we're talking pi over 6, how many pi's over 6 is this one? 3 pi over 6. So if we kind of split this up into thirds, 1 pi over 6, 2 pi over 6, 3 pi over 6. Yes? So 1 pi over 6 would be approximately here. I'm going to do this. This is going to be 1. This is going to be a half, just so we can really maximize our graph. So when this angle in your unit circle opens to pi over 6, your opposite side length, we talked about our 30, 60, 90 triangles, right? If the hypotenuse is 1, isn't the side opposite your 30 degrees half of that? So it's a half. Your opposite is a half over your hypotenuse is still 1, which is a half. Sine of 30 is a half, or sine of pi over 6 is 1/2. Good? Then we move to 45, or a pi over 4, which is going to be right on this grid line, yes? 0 pi over 2 pi over 4. So the sine of 45, if we open this up to a 45, 45, 90 triangle, we talked about our 45-degree reference angle, 45, 45, 90 triangles, all the same. Your opposite side is root 2 over 2, right? It's your hypotenuse, which is 1, divided by root 2. That's the special right triangle rule. And then when you rationalize that, it becomes root 2 over 2. Root 2 over 2 is approximately 0.7. Let's see. Root 2 over 2. 0.7-ish. So when I'm graphing this pi over 4 point, 0.7-ish, that's 0.75, so 0.7-ish would be approximately there. What's that, Josh? Okay. And then when we go to pi over 3, sine of 60, we get root 3 over 2. Okay, again, see how my leg, as I open this up, keeps getting longer and longer? On a smaller angle, the opposite side was pretty short, but as this angle is growing, the opposite side is growing as well. That's why these numbers are growing. That's why we're increasing in here. Okay? So root 3 over 2, 0.86, I think, something like that. 0.87, so 0.9-ish. Root 3 over 2 is 0.9-ish. We're at sine of, what's that, pi over 3? So a third of pi. 1 pi over 6, 2 pi over 6, 3 pi over 6. No, I did that wrong. This is 3 pi over 6. How did I split? Oh, I split it into thirds, didn't I? So, this is 3 pi over 6. 1 pi over 6, 2 pi over 6. No. Oh, okay. 1 pi over 6, 2 pi over 6, 3 pi over 6. So I'm at 2 pi over 6 then, with pi over 3. Yes? So go up to 0.9-ish. And then, of course, pi over 2 is... Thank you. is 1. And that's because our terminal ray has gotten to the top of the unit circle. So our opposite side is technically 1 over the hypotenuse is still 1, so we get a value of 1. Then as our terminal ray kind of moves over here and kind of is coming down, this opposite side is still positive, agreed? So we're still going to be above the x-axis, but it's shrinking as I go down. So these values are going to be exactly symmetrical to what we had on this side. So when we do 2 pi over 3, we're at 0.9-ish. Again, we can split this into thirds again between pi over 2 and pi. That's 0.9-ish. Then our 3 pi over 4 is the 0.7-ish. Then our 2 pi over 3, 2 pi over, wait, no, I'm not right on that. 2 pi over 3, 5 pi over 6. And then when we get to 6 pi over 6, we're here. Okay? Now, this is quadrant 1. Agreed? Okay? Your opposite side is growing. So you're increasing. Between pi over 2 and pi, this is quadrant 2. Your opposite side is still positive, but it's shrinking. Yes? Now when we jump down into the third quadrant, I'll just draw any terminal ray here. Our opposite side is growing again, but in the negative direction. Yes? So it's technically decreasing down until we get to 3 pi over 2, where we'll be a negative 1. So I'm just going to kind of jump this quadrant. But this is quadrant 3, where the opposite side is negative, and therefore sine is negative as we kind of decrease all the way down here. Does this make sense? And then this is quadrant 4, where if I draw a terminal ray, your opposite side is, oops, sorry, here you go. As we go this way, your opposite side is shrinking again down towards 0, but it's still negative. And so here we are approaching 0 again. Does that make sense? Yes? I'm going to pull up an animation on your adjacent side is at its maximum size. And then as you go around this unit circle, look at your adjacent side, keep shrinking, shrinking, and shrinking, and therefore this is coming down, 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 down. And then your adjacent side, as it's shrinking in, you are watching it shrink, is eventually going to shrink into 0, right about there, and therefore our cosine curve is right at 0 at the pi over 2. Yes? So our terminal ray has opened up to pi over 2. Our adjacent side is pretty much non-existent right now, so it's 0 over 1, and that's why we're at 0 there. Now as we go into the second quadrant, our adjacent side starts growing again in the negative direction, because we have a negative x coordinate. So this is going to start increasing or going away from 0 in the negative direction until it gets to its absolute maximum negative side. Okay, when it gets to negative 1 at pi, we are pretty much at the minimum of our cosine graph. Then we swing into the third quadrant, and our cosine, our adjacent side, starts shrinking again up towards 0. Shrinking towards 0, and there it's just about 0. Getting really close, so we're very close to 0 with our adjacent overhead quadrant is going to be 0 over 1. And as we go into the fourth quadrant, it's growing again. So it's positive again, and it's also getting larger and larger until it gets its maximum again, right about now. As that triangle comes to completely close. Yes? Okay? So what we see on this one, and I did it on the sine graph on your paper, put your cosine quadrant. Here's Q1. Here's Q2. Here's Q3. And here's and you know from cosine is positive in the first quadrant, so we're above the x-axis. It's negative in the second quadrant and in the third quadrant, so it's below the x-axis in the second and the third. And then when you get to your fourth quadrant, it's positive in the top. Yes? I know you don't care. I know, I think, the cosine is there in the maximum and and just like this is going to keep swinging around, when it goes beyond 2 pi, the values will start repeating themselves. And so if you go beyond 2 pi, here, your cosine curve is continuing. What do you think about it? Like, feels good? Is that good? What kind of music are we doing? You do? Let me see if I can turn. I thought I did get rid of the mute button.